All right, our last section. So far, we've done measures of, yes. Yep. Measures of central tendency. That's your mean, median, and mode, the one number to describe the whole data set.
All right.
Guys, listen. Then we did measures of variation, how spread out our data are. We did range, variance, and standard deviation. Now our last section are measures of position.
Is this like a day one or just the last?
I don't know how far we're going to get.
Okay.
So we're just going to wing it. Measures of position. Where is my data value compared to the rest of the data values? When you got those seniors that have their ACT score back, you probably saw a percentile score on there. Did you notice a percentile?
No.
Okay. Juniors, when you get yours back, you're going to see a percentile. That is not a percentage. That's not a. It's where you are at compared to everybody else. So we'll talk about percentiles in a minute. So measures of position talk about where one data value is in reference to everything else, like the minimum. You know, you were the maximum. You were the highest. So it's where a data value is compared to the rest of the data. So what we're going to be talking about are fractals. Fractals are values that divide an ordered set into approximately equal parts. You've experienced a fractal before already, and it is the median. What does a median do for us? Even though that was one of our measures of central tendency, what does a median do? What is it? What is the median value? It's the middle. It tells me what the middle score is, so half my scores are above or below, or half my scores are at or below, at or above or at or below. So the median is the fractal that divides the set into two equal parts, approximately equal parts. So divides the set into two approximately equal parts. That's an example of a fractal. The most common fractals used in data sets in statistics are quartiles and percentiles. Those are your two most common ones. So those are the ones we're going to focus on. So our first one, quartiles. It's an example of a fractal, yes. So there's two common ones that we're going to focus on, quartiles and percentiles. And then there's a few other ones, but we're going to go with the two main ones. Quartiles. What are the quartiles going to do? How many equal parts do you think we're going to divide the data set? 4 equal parts. So quartiles divide the data set into 4 approximately equal parts. How many quartile values are there going to be? Think about a board. If you were going to take a long board and cut it into 4 equal parts, how many cuts would you have to make? 3 cuts. So there's 3 quartiles. So if I had a board, we'll just relate it back to woodshop here. If I want to cut this board into 4 equal pieces, I have to make 3 saws, 3 cuts. So quartile 1, quartile 2, and quartile 3. And those are all supposed to be evenly spaced. They didn't do a very good job. So what's quartile 2 doing?
It's the median.
It's the median. Quartile 2 is your median because it's cutting it right in half, the bottom half from the top half. Quartile 2 is your median. So each of these will contain 25% of the board, or 25% of the data. So, let's go. I'm going to go give you 13 test scores. I'm going to give them to you in order. And when you're ready, I'm just going to read them, and you'd be better off just to copy and quit bopping, don't bop your head up and down. So if you're ready for me to start reading?
We're going down like.
I'm going to go from the smallest to biggest. I'm just going to write them in a row this way, just like the board, because then we're going to find the quartiles.
Should we write them down?
I would write them across this way. Okay, you ready?
Hold on.
Lowest score, 42, 68, 70, 72,
Wait, hold on. 42, 68.
70, 72.
Okay.
88, 88, 89, 90, 93, 94, 94, 98, and 99. Okay, I'm going to ask you to find the 3 quartiles for this data set. So the quartiles are going to divide it up where approximately 25% of the class is here, 25% in the middle, 25 here, and 25 here. So where do you think we should start finding quartiles at? The middle first. Let's find the middle. I have 13 values, so where's the middle going to be at?
89.
89. You just count back in. So this is quartile 2. This is our median. So what that says is about half of the class is at 89 or above, had a score at 89 or above. Half of the class had a score, approximately half. These are all approximates because you got the odd number in here. Half of the class is at 89 or below. That's what that tells us. Now we want to find quartile 3, the upper 25% from the lower 75%. How am I going to do that?
Isn't it 94, 98, 99?
Think about this chunk here. We want halfway through here.
You have to take the median,
So you're going to take the middle of these. What's the middle of these?
94.
Well, it's the middle of 294, so that's going to give us a 94. So a 94 is going to be quartile 3. So that tells me about 25% of the class got a 94 or above, 75% got a 94 or below. And then for quartile 1, we do the same thing. Take the middle here. What's the middle here going to be?
71.
71. So that's separating the bottom 25% from the upper 75%. Okay. Do we have to do these by hand?
No.
No. We're going to use a calculator for these.
They're going to take longer to put them together.
Well, this one is because we already did it, but I want to talk about where it's at. So you enter the values into list 1. And then run your 1-var stats. That 1-var stats has so much useful information in it. So let's just take the time to do this so you can practice it and see it. How's that phone working for you?
Good.
Good, nice.
I'm doing it short. don't
Okay,
worry.
I'm now waiting for you.
Okay.
All right, so if you run your 1-bar stats, the first screen doesn't look like anything impressive, but if you arrow down, there's the min. Oh, remember I told you Q1, you would know what that is? Now you know what Q1 is. Matches our 71 that we got here. Okay, median, you have to know that median is Q2. It's not going to say Q2 because median's the more common name for that middle value than Q2. We got, and then Q3. So they're all in order right there.
That's pretty nasty.
So it's right there. So we have to write them out in order and then do it by hand? Only if you want to. It's up to you. I don't care how you do it. We have the technology. We're going to use all technology from here to the end of the semester.
Sweet.
Yes. Okay, so that's done. I don't think I want to go with that outlier bit. I better give this definition though.
Is that a Roman numeral 2?
Yeah, there will be. Just not yet. Interquartile range. Interquartile range. Well, what do you know range to be? Definition for range. A span, a distance, a span. Interquartile range. What do you think that's talking about?
Range for the quartile.
What do you think the interquartile range is?
Between quartiles.
Between which two?
Quartile 1 and 3.
You are correct. The interquartile range is the distance between Q1 and Q3. It's the middle 50% of your data. How far apart are they? So, that was a very good guess on your part. Interquartile range is Q3 minus Q1. It's giving you the range of the middle 50%. The reason we talk about interquartile range, remember when we first started this chapter, we talked about outliers, data values that were far removed from the rest? Well, we need a definition of how far away is far removed. And this interquartile range is what you use to decide. Oh, I forgot my Q1 here. So, what it does is it helps identify outliers. Sometimes if you have outliers in your data, say you're the statistician, you can leave out your outliers. Then you can make a little note, I've left out the outliers, because they can skew your data. Remember we added the outlier in, what it does to an average? It really skews the average, it pulls it towards that outlier. So back on this, do you think we have an outlier in here?
No. 42.
42 is low. Is it low enough to be an outlier?
No.
We're going to check.
Okay.
We're going to check to see if 42 is an outlier. And we have a formula for it. So, helps identify outliers. What you're going to do is find 1.5 times that interquartile range, Q3 minus Q1. 1.5 times that interquartile range. We're going to let this equal, I don't even know what letter to call it. Let's just call it A, an amount. And then you're going to check two things. If a data value is less than Q1 minus A, then you are an outlier on the low end. Then it is an outlier. on the low end. If a data value is larger than Q3 plus A, then it is an outlier on the upper end.
Is this gonna take a lot of space?
Just 2 calculations. Is 42 an outlier? That's our question. So this is what we've got. Well, I'm not even going to draw a picture, but I don't think. Are you ready to do it? So we're going to check 1.5 times Q3 minus Q1. So 1.5. What was our Q3 value? What was our quartile score?
94.
94. Our Q1 was 71. So 1.5 times that range. (94 minus 71 times 1.5) It's 21.5.
Oh, wow.
Okay.
No, you put minus.
Seriously.
You put minus.
Oh,
Yeah.
20. Oh,
Say I got
gosh.
34.
Times 1.5. Oh, my bad. 34.5. Okay.
That's why I said wow. Because I was like, oh, okay. Oh, wow.
34.5. So, I found my amount that I need to be away from my quartiles. What do I do with this 34.5 to check on the 42?
71 minus.
I take Q1 and subtract that amount. What was my Q1?
71
71 minus that 34.5.
gives you 36.5.
So I would have to be below 36.5 to be an outlier. Anything below this is an outlier. So anything
Wow, 2 lines, she said.
below
2 lines.
36.5 is an outlier. So is 42 an outlier? No. You could have easily put that on 2 lines.
I put mine on 3.
Yeah, minus 3.
Because you could have done these 2 things on the same line if you really wanted to, I'm sure.
Is that it?
Yep. What?
Wait, for notes.
Well, we know 42 is not going to be an outlier in the upper end. And you know everything's kind of bunched together here. It's got to be far removed. I mean, all these are clumped together. There's not going to be an outlier here. Just that 42 is, it's lower than 68, but is it low enough? That's what we had to check. I mean, because everything else is kind of consecutive here. There was a big gap here. We wanted to see if it was far enough away to be considered an outlier. So I would not be allowed to throw away the 42 when I do my statistics on what's the class average, the mean, or average and standard deviation. Okay. I think that's it for quartiles. Oh, no, I'm not. That's not it.
I thought we were done.
Oh, no, we're not even close yet. Box and whisker plot.
Oh my god, I love these!
You love these? Box and whisker plot.
No, just give them a chance, Alexa.
How much?
Long.
It's box and whisker. Is this the funny?
It is not.
When is that gonna happen?
When we're all done.
Another, like, in quartile range thing.
I have this like an outline mold.
Box and whisker plot
Yeah, scooch.
is a graph that uses the quartiles.
It's really not. Everyone just took a poop punch
You need 5 values. Well, you need a number line.
I seized the moment.
You need your min and max. And then you need all 3 quartiles. So we're going to make a box and whisker for those test scores. Okay, you need a number line that goes from your min to your max. So if we go back to that,
So, how much space is this gonna take up?
that much? This? Okay, so we need a number line that goes from our min to our max. Our minimum value was 42, and our max was 99. So let's just say our number line is going to start at 40 and go to 100. Okay, so we're going to make a number line that goes from 40 to 100. Do I need every single tick mark in there? No. So I'm going to let this be 40, and I'm going to count by 5s. That'll be good. Well, I'll put a tick mark every 5. 45, 50, 55, 60, 65, 70, 80, 85, 90, 95, 100. Okay. So you need a number line, min to max. Now you want to mark the 5 key values. You want the min, the max, and the 3 quartiles marked with a dot. No. So I'll write them down here so we know where they came from. I'll write them. Min was 42. Max was 99. Q1 was, where's my sheet? Over here, 71. Q2 was 89, and Q3 was 94. Okay. So put a dot above your number line at those 5 values. All right, it's box and whisker. It should be called box and whiskers because there's 2 whiskers.
So now, you connect the second dot over from both sides and create a box. And then draw the line down the middle where the other one is.
Could anybody do what she just said and make it look right?
No.
You know what you're doing. You didn't say it were a hill of beans. All right, the whisker. Whisker is on the top and the bottom. First thing, it starts with the whisker, ends with the whisker. The whisker is just a little line that connects here. So it's connecting Q3 to the max, and at the bottom end is the whisker. What that is telling me is there are as many test scores in this little chunk as there are down here. Just means that the bottom 25% of scores are more spread out. The upper 25% of the scores are all clustered together. Then you put a box around the middle 50%. So that box contains the middle 50% of your data. 50% of the class scored in between 71 and 94.
Sure, that's exactly what I told you to do.
Well, you didn't say it very well. Then this lonely dot in the middle, what is that dot representing again?
The median.
The median. You just mark it with a bar. So you have the same number of scores in this whisker as you do in this part of the box, as you do in this part of the box, as you do in this bottom whisker. So the bigger the box or the bigger the whisker just means the data is more spread out there. Are you good with that? Okay. You can make the calculator give you this box and whisker, which we're going to do right now.
This is your longest day of notes.
Is it? Box and whisker
Be that abrupt.
on the calculator. So enter data in a list. This will be the last thing. I'll do the percentiles tomorrow. Enter data in list 1, which we already have. List I. List 1.
List I.
List 1.
That's
I
an
tried
I.
to scribble that out.
That's like just dotted your eye.
Okay. So, now to make the graph happen, you're going to go to stat plot, which is right above your y equals. See it in yellow or whatever color you have above the y equals? So I'm going to go second y equals. And it should say stat plots across the top. Everybody there? Stat plots? Okay, press number 1 because we're going to turn one of these on. Obviously, turn one on.
Wait.
Okay. Okay, and there's different, these are statistical graphs that it can make. And when you go down to type, there are 6 different types of graphs you can ask it to make. First one's a scatter plot. Next one is a connected line graph. Next one is a histogram. Now I see 2 box and whiskers. The first box and whisker has 2 little dots to the right there, and then the second one doesn't have those dots. What do you think those 2 little dots represent? Outliers.
I have a quick question.
Yes.
How do I get to that? I click second and stat plot.
And then number 1. Or enter on number 1. Okay? We want the, let's go with, for the middle one, because we know we don't have any outliers anyway. Now you tell it which list you want it to use in your calculator. Where have you put your data at? Mine's in list 1.
I have an X and Y list.
Your X is your list 1, I think.
Y is
No, we don't want list 2. We don't want, are you sure you have X and Y? Are you in the right graph?
I have X and Y.
Are you sure you're not in scatter plot?
I clicked on it. You have to click on it. Oh, okay. That's
Okay.
Second stat.
And then frequency is 1. Okay, now, after you fill all that in, you want to go to Zoom. And you're going to look, arrow down and look for Zoom Stat. That will set up the window for you. So Zoom is on that top row of buttons. You see it right in the very middle? And Zoom Stat is down hidden somewhere. Number 9 on mine. How is it on the new ones?
Do I click enter anywhere
Nope.
after this part?
And there it is. You can trace. If you press trace, see it on the top row? It starts on the median, and you can go left and right and get your quartile values, your max. It kind of tells you everything.
Why is it like way in the
Whoa.
air?
Why is what?
Why is it way in the air?
Why is it? Oh, I don't know why it sets it like that. Yes. Come up.
It says you don't have, she doesn't have the same.
I don't have.
Oh, you didn't put the data in. You don't have the data in the list.
What do you hit after that?
Zoom stat. Go down. It's like number 9.
What, okay.
And then hit enter. Okay, now I want you, just so you're not screwed up next time you want to make a graph, I want you to press your y equals. Press your y equals real quick. Y equals. I've got a graph in there from a line of some kind, but see on the top, see how plot 1 is highlighted? That just means it's turned on. And sometimes the graph won't graph both things at the same time. It'll give you a little error. If you just arrow up and hit enter on it, it'll turn that off. So you can shut them off that way, or you can go back into stat plot and shut it off. But sometimes if your calculator won't graph, it's because there's a stat plot turned on and then maybe a parabola down here, and it can't do both at the same time, and it just stops.
Yeah.
So you got to shut one or the other off.
So that was my problem during the ACT.
Oh, was it during the ACT? So you can shut that off if it's not graphing. Shut one or the other off.
Where
Okay.
is this word plot at?
Stat plot? Right above the y equals where I said.
Oh.
Oh,
Oh, geez.
maybe if you weren't on your phone, you'd have heard me.
I wasn't on my phone
Oh,
last time, Short.
oh.
What are you guys arguing?
I'm not
Okay,
arguing.
let me find some homework.
Yelling at me.
So we will save percentiles for tomorrow. It's just very short.
Wait, did you
But
say
we'll save it.
unhighlight plot 1? Where's the short?
What?
You say to unhighlight plot 1?
It just shuts it off.
What does that do for us though?
I tried to explain, if your calculator won't graph, it's because both things are turned on. You got to shut it off. All right, everything except for percentiles, which is at the end. All right, so let me see. Page 90. 1 through 6. 1 through 6.
And we're done.
10 through 18 even.
Thank you.
And 19. Okay, we'll hit percentiles tomorrow real quick and start the chapter review.